Hello everyone. So today we are going to start our week 8 of machine learning foundation. Particularly for this week content, I will try to explain the concepts by using some activity questions and practice assignments. Okay, so let's start. So the first topic of week 8 is intro to optimization. Okay, so if we try to summarize machine learning foundation, it will be in three types. Or you can say there are three major pillars of machine learning foundation. Suppose P1, P2, P3. So the first pillar is linear algebra. Linear algebra. As you might have seen in most of the machine learning foundation questions, we have to use the linear algebra concept for solving the particular question. So the first pillar is linear algebra. Second pillar is probability. Okay. Second pillar is probability, and third pillar is optimization. Okay. So if we try to explain uh, the three pillars, so linear algebra majorly focuses on structure and relationship between the data. So we study the structure and the relationship between the data, between the provided data to the model. We have to use linear algebra for that purpose. Okay. What does probability do is probability helps to handle the uncertainty and randomness in data. Okay. So basically for noise, noise and variability in real world. Okay. So basically it helps to modify the data like removing the uncertainty and randomness and correcting the data into a particular, you can say in a specific manner. Okay. So it will be easy for us to understand and solve the problems related to the data. So this is the work of probability. Now optimization. Okay. Optimization among the three pillars of machine learning foundation, optimization is the best model. Why best? Because this optimization model achieves, you can say the best performance by doing by so you can say by studying the data and in such a way it minimize the error and maximize the reward. Okay. So that's the only thing which we want from a machine learning model, to minimize the error given in the data and perform the actions to maximize the reward. Okay. So among the so these are the three pillars of machine learning foundation: linear algebra, probability, and optimization. And among the three models in the machine learning foundation, optimization is the best model. Why is it so? Because in it performs the it it achieves the performance in such a way that it minimizes the error and maximizes the reward. Okay. So this is activity 8.1. Linear algebra in the context of machine learning. Linear algebra to find the structure and the relationship between the data. So first option is correct. The notion of probability in the context of machine learning can be model noise in the data. Okay, as we have studied there, this model noise in the data is done by the probability model. Which of the following helps in getting the best model out of all the possible models? Optimization it is. Okay, so this 8.1 completed. This is 8.2. The best models are those that minimize the loss and maximize the reward. Maximize the loss? No. Minimize the reward? No. Okay. In every optimization problem, there is a function that we want to minimize or maximize. The function is called objective function. Okay. See. Okay. So you can say basically in optimization, we will be having a function. This is the objective function. Objective function. And with this objective function, we have to perform uh, two constraints. Okay. First is equality constraint, and second is inequality constraint. Inequality constraint. If we want to study them separately, so if we talk about equality constraint, equality constraint basically this specifies that a function must be exactly equal to a certain value. Okay, so equality constraint means suppose if we have a function h of x is equal to 0. This is equality constraint, and this is 0 for all values of j belonging to 1 up to the value of k. So this specifies that a function must be exactly equal to a certain value. Now, if we talk about inequality constraint, and uh, inequality constraint specifies that a function must be either greater than or equal to or less than equal to a certain value. Suppose we are having a function gi of x is maybe it will be greater than equal to 0, or we can say gi of x is less than equal to 0. So this less than equal to or greater than equal to, these both are inequality constraints. Okay. So in every optimization problem, there is a function we want to minimize or maximize. The function is called objective function. The restrictions imposed on the variable of an optimization problem can be either an equality constraint or an inequality constraint or both. Okay. Yeah. Not a single equality constraint, not only inequality constraint, either equality or inequality. No, it can be both. Okay. Which of the following are a part of a general form of optimization problem? So it will be an objective function. We can perform an equality constraint, or we can also perform an inequality constraint. So all of these is the answer. Any maximization problem can be converted into an equivalent minimization problem. Okay. Suppose suppose we are having a function fx and we need to maximize it. Okay. We need to maximize a function fx. And the question is, any maximization problem can be converted into an equivalent minimizes problem. Okay. So if we replace this x with minus x, okay, and if the function is an odd function, so generally, if any one of you don't know about odd and even functions, suppose we are having this function sine function. Okay, or this is not relevant for this topic. Okay. So basically, the difference between even and odd function is if a function f of minus x is still equal to f of x, okay, it will be an even function. And if f of minus x is equal to minus of fx, this is an odd function. Okay, so if we want to minimize the function fx and we have to maximize, suppose any maximization problem can be converted into an equivalent minimization problem. Okay, if we replace this x with the minus x, it will be minimizing of minus of fx. Okay, so maximizing fx is same as minimizing minus of fx. Okay, so that's the condition. Yes, we can solve any problem which where maximization is equivalent to minimization. Okay. Now, in the cow example discussed in the lecture, if the cow is tied to a rope of length 16, fixated at a point of 10, 15, and the perpendicular fence passes through 25, 0, then the constraint would be would be here. Okay. Suppose if we tie a cow with the rope of length 16, okay, so it can travel in this way also. No? It can travel in this way. So we can say that the radius is 16, okay, and uh, and this is forming a circle. So a general equation of circle is x minus a whole square plus y minus b whole square is equal to r square, where r is the radius of the circle. So what is a comma b? A comma b is 10 comma 15. So x minus 10 plus y minus 15. Now it can like you can say the maximum distance it can cover is 2 pi r. Okay, the circumference of a circle, 2 pi r. So and we need to find the you can say the constraints. Okay, so it can maximum cover the distance 2 pi r. So it will be less than equal to 16 square. Okay, it cannot cover more than 16 square. Why? Because 16 is the only radius. Okay, suppose you are having a circle and the radius is 16, so it cannot travel like this. Okay, so the constraint will be less than equal to 16. Now the perpendicular fence passing through 25, 0. So it depends only on the constraint x1. X1 will be less than equal to 25. Okay, it cannot cover more than 25. So option C is correct. X1 minus 10 whole square plus x2 minus 15 whole square is less than equal to 16 square, comma x1 will be less than equal to 25. Okay, what will be the value of x for which this will be minimum? Okay, so if the function is like x minus 3 whole square, so the method to minimize the function will be differentiate it and equate it to 0. So the differentiation of this function will be 2 times x minus 3 is equal to 0. So x will be 3. The value at which the x will be minimum is 3. Now, for the above problem, what is the minimum value of the objective function? So the value of the objective minimum value will be double differentiated. Okay. So after doing again the differentiation of this function, it will be 0. Oh, sorry, wait. So, oh, sorry, we need to find the minimum value. Okay. So the value at which the function will be minimum is x is equal to 3. If we put the value of x in the given function, so it will be 3 minus 3 whole square, that is equal to 0. So the minimum value will be at 0. Okay. Yeah. What is the solution of the following constraint optimization where we have to minimize the function 2x minus 18 whole square? So your function is 2x minus 18 whole square. Now we need to, you have to, what is the solution of the following uncon unconstrained optimization problem? Okay, so unconstrained means there is no constraint applied here. Like there is not any equality constraint or inequality constraint, but the only method to minimize the function is differentiate the function and equate it to 0. So it will be 2 times 2x minus 18 is equal to 0. 2x minus 2x will be equal to 18, so x will be equal to 9. So the value of x at which the function will be minimum is x is equal to 9. Okay? Yeah. In the general approach to solve an unconstrained optimization problem discussed in the video, what is the form of the update rule? Okay, so let's find another page. So the theory is in unconstrained, sorry, unconstrained optimization update. So we update the variable x iteratively to reach the optimal solution. Okay, so the general form of update rule will be update rule is x of t plus 1 is equal to x of t plus d. Okay, this is the update rule. So x of t plus 1 is equal to x of t plus d. Okay, now this rule can be further derived as to, you can say, this used in optimization algorithm like gradient descent. Okay, now for the general form of gradient descent, it will be x of t plus 1 is equal to x of t minus, this is the step size, or you can say learning rate. This will be equal minus step size into the gradient of the function. Okay, so this is the update rule and this is the gradient descent. Okay. In the general approach to solve an unconstrained optimization problem discussed in the video, what is the good direction to move? Okay, it is asking to in the which direction we should move. Okay, so for unconstrained optimization problem, we need to minimize the function. Okay, so for minimizing the function, we have to move in the opposite direction of the gradient. So for moving in opposite direction, we will use d is equal to minus f dash of x. And if you see the update rule is like t x of t plus 1 is equal to x of t plus d. Okay, and the gradient descent rule is x of t plus 1 is equal to x of t minus step size of f of x. So you can say that d is like minus of gradient of x. So to minimize the function, we should move in the opposite direction of the gradient. Hence, d is equal to minus of f dash x is the, you can say, the most appropriate direction we should move. Assuming f of x is equal to x minus 8 whole square, and the initial guess is this x naught is known as initial guess. Using the update rule, what will be the value of x1? So if you put x1 in place of x of t plus 1, it will be x of 1 is equal to x naught mm, plus d. Okay. So what is f dash of x? F dash of x will be 2 times x minus 8, and the initial guess is 10. So the value of f dash of 10 will be 2 times 10 minus 8 will be 4. Okay, and we know that d is minus of gradient of x. So d will be minus of 4. Why? Because the gradient of a function is 4. So d is minus 4. So x1 is equal to x naught plus d. We need to find x1. What is x naught? X naught is 10. 10 minus what is d? D is minus 4. So 10 minus 4, it will be equal to 6. Okay. So that's how you have to use the, you can say, update rule. Okay. Uh, in the update rule where you need to find this f dash of x. So you can say that you have to put the value of the initial guess here also and here also. Okay. As you can see in this question, in place of x of t, I have put the initial guess. What is initial guess? Initial guess is x naught. So x1 is equal to x naught plus d. In place of d, we have to write the negative of gradient. So it will be minus 4, and 10 minus 4 is 6. So the answer will be 6. The value of step size should always be same in each direction. No, okay. So you can say the most advanced equation for the step size will be n naught plus upon divided by 1 plus lambda times t. Okay. As you can see here, this is known as learning rate TK. You don't need to put much focus in this equation. This is not in our syllabus, but just for the sake of, you can say, explanation, I have used this equation to show that the step size is not always same in each iteration. Okay, so you can say that if you want to describe step size, so step size is nothing but adaptive convergence. It usually adjust the step size dynamically based on the progress of optimization. Yeah. So step size is not same in all the direction. It will adjust itself on the base of your optimization progress. Okay. Which of the following is or are true about step size? It is a scalar value. Okay, scalar value, and it is also an integer. It is like, it is not important that it should be integer. Okay, it should not be integer. I mean, it can be integer, but it is not. You can say always true that your step size will always be integer. Okay, integer can be negative and positive, but it cannot be in the decimal. Okay, that's what the definition of integer. But your step size can be 3.4 minus 1.2, 0.4, 1.0, anything. Okay, and it could be a function of t where t is the iteration number. Okay, so x of t plus 1 is equal to x of t plus d. It is depending on t. T is what? T is iteration. Suppose in the previous question, I have found that x1 is equal to x naught plus d. This is the first iteration. If I say x2 is equal to x1 plus d, this is the second iteration. X4 is equal to x3 plus d, this is fourth iteration. Okay? Yeah. What could go wrong if we use n of t is equal to 1 divided by 2 raised to power t as a step size? So if step size become too small and we may not be able to reach the optimization value of x. Okay? And which of the following is or are two good choice for the step size? As I have shown you in the step size learning rate DK. So it will be E of t is equal to n naught plus 1 plus lambda t. Okay. If you write it in the simpler way, it will be step size is equal to 1 upon t plus 1. So this is the, you can say, the best choice for the step size. Okay. The general form of the update rule for solving an unconstrained optimization problem in the gradient descent rule is x of t plus 1 is equal to x of t minus step size into gradient of function. Gradient descent algorithm converges to local minimum. Okay. So, okay. So let's take another page. If we talk about gradient descent, so it moves toward the minimum but does not guarantee finding the global minimum unless the function is convex. So gradient descent will try to find the minimum value, but it does not guarantee finding the global minimum unless the function is convex. Okay. So for the convex function, you can say if the convex function is in the shape, if the function is in the shape of a bowl, then the function is a convex. And if you want to describe the convex function in terms of mathematical representation, it will be f of lambda times x1 plus 1 minus lambda times x2. It will be less than equal to lambda times f of x1 plus 1 minus lambda times f of x2. Okay, this is your convex function. So gradient descent algorithm converges to local minimum, not the global minimum, not the local maximum, and not the global maximum. Which of the following is true for x dash to be a global minimum? So f dash of x should be less than equal to f of x. This is the condition you have to keep in your mind. Okay. This is a local minimum. This is local maximum. This is global maximum, and this is global minimum. Which of the following are function for which local minimum is always the global minimum? Okay, so these three are the quadratic function. In the quadratic, there is only one global minimum and there will be only one global maximum. If we talk about sin x, the function of sin x will be like this. So as you can see, all global minimum and global maximum are on the same height. So there will be the global local minimum will be as same as global minimum. Okay, so all the options are correct. Using Taylor series extension, we can obtain global information using local information for a function. Okay, so Taylor series, Taylor series is, you can say, 90% similar to your linear approximation function. But linear approximation function was like will we have exact function, so it will be f of x comma y plus df upon dx into x minus a plus df upon dy into y minus c. Okay, so Taylor series, the expression is f of x plus h. It will be equal to f of x plus h times f dash of x plus you can say h times of. So okay, so you need only this much value. Then so Taylor series is done. Gradient descent, we want to choose the direction d such that this Like this will be local minimum. Gradient descent always goes for local minimum. So f of x plus step size b minus f of x should be less than 0. Okay. In the gradient descent, a fixed value of d direction d can work for all possible points x. No, not the all possible points. It will be goes for only local minimum. And this question is from the lecture. You can do it on your own. In the gradient descent algorithm involving higher dimension, we compute gradient descent of derivative. Yeah, true. The general form of update rule in case of higher dimension will be x of t plus 1 is equal to x of t plus this is your step size minus gradient of x of t. So the fourth option is correct. Delta f of x gives the direction of steepest ascent. Okay. If you want to find the direction of steepest descent, you need to find the minus negative gradient of your function. Negative gradient function is the only direction which minimizes the function of fx. No, it will be it will maximizes the value. For a function in the higher dimension, how many possible gradients exist? So it will be infinite gradient because for higher dimension, uh, it will be like you you can you can say how many possible gradients, right? So you can find the gradients in almost n number of directions. Okay, so it will be infinite direction. Okay, now so this is practice assignment. So two positive numbers have sum of 60. So if I say x plus y is equal to 60, what is the maximum product of one number times the square of another number? So we need to find the maximum product of xy square. Okay, xy square and y you can write it as 60 minus x. So your function will be x times 3600 minus 120x plus x square. So it will be 3600x minus 120x square plus x cube. Now you can differentiate it. So differentiation it will be 3600 minus 240x plus 3x square equated to 0. So it will be x square minus 80x plus 1200 is equal to 0. So it will be 80 plus minus 40 divided by 2. So it will be 60 comma 20. Okay. So 60 comma 20. So the less value will be x. So this can be x. Okay. And we need to find the product. The product will be 20 into 40 square. Why 40? Because 60 minus 20 is 40. Okay. 20 into 40 square will be 3200. Sorry, 32,000. So B option is correct. The point on which the point on y is equal to x square plus 1 closest to 0.1 comma 1.5. Okay. If we try to apply the distance formula here, so distance formula, let's take a random point x comma y. Okay. So in place of y, I can write x square plus 1. Now find the distance between these 2 points, 0 comma 1.5. So it will be x minus 0 whole square under root plus x square plus 1 minus 1.5 whole square. So it will be x square plus x square minus 0.5 whole square. This is D. If we do square on both sides, so it will be f of x is equal to x square plus 0.5 x square. So it will be, you can say 4x cube. Okay. So if you equate 4x cube is equal to 0, you will get x is equal to 0. And if x is equal to 0, y is x square plus 1. So y will be 1. So the points will be 0, comma 1. So 0, comma 1 is the answer. The volume of the largest cone that can be inscribed in a circle of a radius 3 meter. Okay. So there is a short trick of doing these type of questions, these third and fourth type of questions. So for cone to be inscribed in a circle, you can use the short trick as 4 by 9 pi r cube. Okay. 4 by 9 pi r cube means 4 by 9 into 3.1416 into what is r? R is 3, so it will be 27. 9 times 3, 27. 12 times 3.1416. So it will be 33 point, you can say 33.51. Okay. So 33.51 will be answer. And for the area, for the rectangle to be inscribed in a circle, the short trick is, you can say 2r square. 2 times, what is radius? 4 square. So 2 times 16 will be 32. Okay. So these two tricks, okay. For cone to be inscribed in a circle, you can use 4 by 9 pi r cube. And for rectangle to be inscribed in a circle, it will be 2r square. These two tricks you have to keep in your mind for solving the question within 5 seconds or 10 seconds. So these type of questions are very theoretical questions. Okay. A manufacturing plant produces two products M and N. Maximum production capacity is 700 for total production. At least 270 units must be produced every day. Machine hours consumption per unit is 6 hours for M and 5 hours for N. At least 1100 machine hours must be used daily. Manufacturing cost is rupees 25 for M and 35 for N. X1 be the number of units for M and X2 be the number of units for N. The objective function for the above question will be, okay. So the objective function will be, um, 25 for M and 35 for N. 25x1, 35x2. Okay, 25x1, 35x2. So this will be your answer. Simple. The constraint due to maximum production capacity will be, if we want to find the total capacity, they're saying that the maximum, it will be, uh, so x1 plus x2 will be greater than equal to 700. Okay, greater than equal to 700. Why is it so? Because it is saying that the maximum production capacity is 700 for total production. Okay, so for x1 and x2, the capacity will be greater than 17. Okay, for wait, sorry. It is saying that the maximum production capacity is 700. So maximum it can go to 700. So the option A will be correct because it cannot go further further 700 because the maximum capacity is only 700 for total production. The constraint due to minimum production capacity. See, minimum production capacity, it is saying that at least 270. That means minimum can be 270, but it can go further 270. Okay, x1 plus x2 can be greater than 270. So option D will be correct. The constraint due to machine hour consumption, it will be 6 hours for M and 5 hours for N. And it is saying that at least 1100 machine hours. So 6x1 plus 5x2 will be greater than equal to 1100. Why? Because at least 1100 hour of, you can say, machine hours must be used daily. Okay. Now these three questions you have to do it on your own. It is same as these type of questions. You can do it on your own. Again, The area of the largest rectangle that can be inscribed in a circle, it is 2r square. 2 into r 1 square, it will be 2. Option D will be correct. Okay, now we need to find the value of approximation. Okay, so the value of approximation, how you will find? See, the value of the function at x equal to 5 is 3.2. And the value of the gradient at 5 is 1.2. Okay, and we need to find the approximate value. The approximate value will be x plus h. It is f of x plus h time f dash of x. Okay, so you can say 5 plus 0.2. Okay, because we need to find the approximate value at 5.2. So the value of x will be 5 and the value of h will be 0.2. So the value of so fx, the value of 5 is 3.2 plus 0.2 into 1.2. So it will be 3.44. So 3.44 is your approximate value. Now, for this question, fx is 1 by 2 x sin x minus 1. Okay, your initial guess is 7 and your step size is 0.25. You need to find the value of the function after 2 iterations. Focus on this thing after 2 iterations. Okay, so first find the gradient. F dash of x will be, I think, it will be 1 by 2 x cos x plus sin x. Now, the initial guess is minus 7. So you need to find the gradient has minus 7. So 1 by 2 minus 7 cos minus 7 plus sin minus 7. You can use the calculator here. So this value will be minus 2.967. Okay. You can say x1 is equal to x naught minus n into f dash of x. So x naught was minus 7 minus your step size is 0.25 and your f dash x is minus 2.967. So this will be minus 6.258. So this is first iteration. You need to find the value after second iteration. Now this is your you can say initial guess for your second iteration. So it will be um, f dash of minus 6.258 is equal to 1 by 2 of minus 6.258 into cos of minus 6.258 plus sine of minus 6.258. It will be minus 3.052. Okay. For second iteration, x2 is equal to x1 minus n times f dash of x. It will be minus 6.258 minus 0.25 into minus 3.052. So it will be minus 5.945. Okay. So this is the value after second iteration. Now you have to put this value into your function. So what was the function? Minus 5.945 will be minus 5.495 into sine of minus 5.495 minus 1 divided by 2. So this will be minus 3.885 minus 1 divided by 2. It will be minus 2.44. Okay. So the value will be minus 2.44. Okay. So that's all for week 8. In the next video, I will try to gather some PYQs of quiz 2 and we'll solve it together. Okay, so actually this is a very, you can say it's a confusing week, and after this week 8, the week 9 to 11 or 12, you can say basically focuses on your statistics 2 foundation part. So okay, after quiz 2, we'll look at week 9 to 12. Till then, take care.